Hi, Alina. Hey, Sumi. Hi, John. Hi, Trisha. Hi, Mia. Hi, Madeline. Hey, Shisti. Hey, Miriam. Welcome, guys. Hey, Charlotte. Cool. We got lots of folks coming in. Awesome. Super excited to see so many people here. Whoa, this is great. Yay. Hi. Welcome to tonight's GRE Free Prep Hour. My name is Kat, and super excited to be here with you on this January night, or maybe morning or afternoon, depending on your time zone. So I just said hi. Yeah, we're going to use the chat to communicate a lot. So say hi in the chat and tell us, have you been to a free prep hour before? And where are you based? And maybe where are you at in your GRE studies? So I actually have a bunch of questions for you right now. Been to a prep hour before? Where are you right now? Where in the world? And where are you in your GRE studies? Just say hi and tell us a little bit about your answers to those questions. Cool. Nice. Cool. All right. Okay, so mix. Some people have taken official tests, some people are new. Very cool. John, a lot of my family is in Maine, in Cape Elizabeth and in Booth Bay, and I love Portland. It's a great city. Yay, I'm in Brooklyn too. I'm from New England originally, but I lived in New York for a long time. And now I'm in Brooklyn. Awesome. Cool. Nice. Yay. I'm glad, Alina, that you've been watching these. I think that these free prep hours, so they get recorded, they get posted on YouTube, and I think they are a really, really great, maybe underutilized resource for studying. Because if you go through these free prep hours, I think you can find pretty much some video on almost every aspect of the test. I was going through them today and I was like, what new thing can I do? And it got kind of hard because we have a lot up there already. So yeah, awesome. Yay, Kristen, glad you found them helpful too. Yeah, so if you're just starting, definitely check out our YouTube channel, look at some of the ones in the past that are posted there. They all have like titles, descriptions that'll make it clear what they are. And that will, I think, be a good resource. So if you're new to the prep hours, the way this works is each instructor, it's usually either me, my colleague Whitney, or my colleague Dimitri. One of us teaches these. We do them twice a month. And each instructor picks a topic and they do that topic for an hour that night. Hopefully someday we will let you know in advance what the topics will be, but right now it's a little bit of a roll the dice and be surprised. The problems we're going to do tonight are going to be drawn from this book, which is a great source of practice problems. It is, I think, a little bit more than 5 pounds now, and has tons and tons of stuff. So all the problems we're going to see tonight are from this book. I decided to do something a little bit different tonight, and we'll bear with me as we try out something a little bit different, a different kind of type of lesson, and hopefully it'll be fun and useful and you will learn a lot. Oh, from Egypt, so cool. Noran, I have never been to Egypt, but it's like a place I would enormously love to visit someday. That's cool. I love doing these too because people come from all over the country and all over the world. It's super neat. We all get to connect online. So what I want to talk about tonight is I want to try to talk a little bit about a question or an issue that my students bring to me a lot that I think is super important, which is, how do I recognize what a problem is about? Like, how do I look at a problem and decide what I should do? And that is a question that doesn't have a simple answer. That's maybe one of the big existential questions of the GRE. So I want tonight to try to talk a little bit about how this works and to demonstrate for you a little bit of how I think about problems that I'm seeing for the first time. So the problems that I'm bringing tonight, I have not really spent a ton of time with. They're problems I obviously have looked at because I made the slides, but I haven't actually solved these before. So you're going to get to see what it looks like when I encounter a problem for the first time, as you will as well when you are on the test or as you're studying, which means also I might make some mistakes. So if you see me make an arithmetic mistake or any other kind of blunder, I am a big one for making small errors. I'm going to count on you guys to catch me if I do. So be alert, be attentive, gold stars to whoever catches my math mistakes. So yeah, I want to talk a little bit about kind of how do we get started? What do we look at when we see a new problem? And then just kind of go through a range of different problems. So if you are totally new to studying, we're going to do a bunch of math problems tonight. If you haven't looked at math in a while, I'd say just, you know, kind of focus on the process side. Don't get too stressed out if some of the math feels like, whoa, overwhelming. You will get there. It will come back to you as you kind of take time to get into this. For folks who've are deeper in their studies, I think this is going to be particularly useful just to kind of see how this goes. And we're going to focus tonight on the problems that are not quantitative comparisons. So not those problems with the two quantities that you compare, the ones that are more like regular sort of math questions, because the comparison questions are a bit different. When I am, when I look at a problem for the first time, really important thing when I start a problem is I take a deep breath. I take my pencil, I put it down, and so I'm calm, I'm focused. And then before I pick up my pencil, before I do any math, I just take a little bit of time to read the question and to think about identifying a few things. And the first thing, super important, is just what is this question asking? What is my goal? Because each question asks us for something a little bit different. So I just want to get really clear on what the question is asking. I also will think about what topic or topics are showing up here. Does this look like it's percents or fractions or probability or a combination of a couple topics, just to kind of get myself oriented in which of the math worlds I'm in the problem. I take a look at the answer choices. This is so important. Those answer choices give you really useful information about how you should approach the problem. So I take a look at those, see if they give me any hints about what I can or should do. And then I think, is there anything here that looks familiar? Have I seen something like this or something like some aspect of this before? That might allow me to say, okay, I know what to do because I've seen something like this before. So I should apply this strategy or this approach. So I take some time, you know, anywhere between 10 and 30 seconds just to process what's going on in the problem, to get clear on what's there. I may take a couple notes as I do this, but I definitely am not going to start jumping into setting up equation solving, putting math on paper. I'm going to emphasize this. Time and time again, I work with students who are super hardworking and very bright and very committed to mastering this test. And I very much believe this is a test that anyone can master with hard work. It is not a test of your intelligence. It's just a test of your ability to take this test. But I see people working super hard and struggling because when they see a problem, they just immediately start trying to do the calculation. And this often gets them into loops where they go down the wrong path, or they get very anxious and kind of freeze, or they take too much time. So especially if you're starting out, build this habit from the beginning. Take a pause at the start of each problem, pay attention to what's there. And that's something I'm going to ask us to do together tonight as we go through some of these problems. I'm actually going to set a timer for 20 seconds. And I want all of us in the 20 seconds as we look at each problem to not do any writing, to just think about answering these 4 questions. So to reiterate, your task tonight as we start each problem is don't pick up your pencil. Just read, notice, think, try to answer these questions here. And I'll put these questions up on the screen with each problem. All right. So let's take a look at one. Let me get my stopwatch set up so I can time us. So I'm going to give us 20 seconds just to notice and think about what is here. All right. So what does the question want? What is my goal? I see I have a couple of equations, and ultimately I need to find G over B. And I often like to write my goal down on my paper so that once I do all my math, I can double check at the end that I've solved for the right thing. All right, now I'm going to ask you guys some questions. You can chat in your answers. What topics appear in this question? What topic or sort of content area could we categorize this as? Yeah, nice. Yep, we've got algebra. Algebra is going to come up a lot. We've got fractions. Awesome. So some combination of algebra and fractions. Now, when I look at my answer choices, I just have this box where I have to type in numbers. So I'm kind of, you know, this isn't going to help me all that much, but I note that it's there, so I have to kind of be able to solve for a single value. And then, oh, Shristi made a good comment. We also see 2 equations and 2 unknowns. So I have 2 variables, B and G, and 2 equations. So what does that suggest about what I should do or where I should start? If I see 2 equations, 2 variables. Yeah, I wanna, cool, I'm seeing some great stuff. I wanna simplify, I wanna isolate one variable, and there's 2 different ways I can do that. There is substitution and there is elimination, or stack and add. Which one do you guys wanna use here? Do you wanna substitute or stack and add? Anyone got a vote? Cool, folks are saying substitute. Yeah, I like substitute because it looks like it's gonna be super easy to isolate G. So I have 2G equals 12B, divide both sides by 2, I get G equals 6B. And now I can plug that into my second equation. So if G equals 6B, 4 times G, that's 4 times 6B, minus 3B equals 63. So I get 24B minus 3B equals 63. 21B equals 63. B equals 3. And I'm writing out all these steps not so that you have to listen to me mutter to myself, but to show you what I actually do on the test. This is what I write. I write down step by step, because if I don't, I'm going to make a mistake. Also, if I'm trying to do too much stuff in my head, I'm going to get really tired. So B equals 3, and I know that G equals 6 times B, so G equals 6 times 3, which equals 18. And we are good. We've solved. Yeah, and this is pretty fun. You could put 18 over 3, or you could put 6 over 1. You can put any form of a fraction into these boxes, any equivalent form of the fraction. So you can reduce, don't have to reduce. All right. Let's look at another one. Same thing. I'm going to set our timer for 20 seconds, and then I'm going to ask you guys some questions. All right. This one's a little bit trickier, I think, for a couple reasons. One is when I think about what do I see in my answer choices, it's select all. So here, when I see these square boxes, I could pick one of these, I could pick 2, 3, 4, or all 5. Any of those could be correct. So I have to think about each answer choice one at a time. I also think this is a little tricky because this is slightly harder to answer this first question. So I'm going to ask you guys, what does this question want, or what is our goal when we're looking at this question? Ooh. Yeah, I definitely want to simplify. Yup, I'm seeing a bunch of people saying prime factor, reduced to primes. Yup, rewrite this expression. How did you guys know, for folks who are saying prime factor, reduced to primes, how did you know that that's what was going to be a good thing to do here? Yeah, nice. I saw in the chat. Yep. I got 3s and 9s, and I got 81 and 27, which are multiples of 3 and 9. So if this is the first time you've ever seen a question like this, you know, maybe take your time. Like, what do I see here? What do I see here? How did these things connect? How do I put these pieces together? Garrett made a great point too. The first time you see a problem like this, it's going to be pretty scary, I think, especially if, like me, or someone who's a little bit nervous about math, sometimes a lot nervous about math. And it's going to get better with practice. You're going to do these over and over again. You're going to see recurring patterns. It's going to improve. So first time's always going to be the worst. Yeah, so we see this. We've got kind of a place to go. We've got a place to start. So I'm just gonna start breaking these down. So 81, if I'm thinking about prime factors, that's 9 times 9. That's 3 times 3. So 81 is 3 to the 4th. 27, 9 times 3, so that's 3 to the 3rd. So I have 3 to the 4th plus 3 to the 3rd. This is still a little irritating because when I look at my answers, I have multiplication, but here I have addition. Has anyone seen something like this before? Does anyone have an idea of what I should do to continue condensing 3 to the 4th plus 3 to the 3rd? Ooh, so what's tempting is to add the exponents together, but that's only for multiplication. So if I had 3 to the 4th times 3 to the 3rd, that would be 3 to the 7th. It's one of our exponent rules. You're just starting out, something you'll come across and memorize, be all set. But here with addition, there isn't really a rule for addition. Yeah, yep. They're good. You want to get them down. Thank you, Patrick. Did anyone have any ideas? Yeah, Vivan has solved it for us. So what Vivan has done is, and this is again one of those things that first time it's going to feel like, whoa, but you're going to see this pattern again and again. When I have two exponents with the same base and an addition, I want to factor something out. I want to factor the biggest power of 3 out of both. So here, biggest power of 3, 3 to the 3rd. That's, you know, there's a 3 to the 3rd in here, 3 to the 3rd in here. So I can rewrite it, yeah, Noran, nice, as 3 to the 3rd times 3 plus 1. So then I'd see, cool, all right, that's going to be 3 to the 3rd times 4. Because if I were to re-expand it, I'd have, ooh, guys, I made a big mistake. I made a big mistake and nobody stopped me. I forgot a step. I told you guys I was gonna, yep, I told you guys I was gonna make a mistake and it's on you to catch me, so. Yep, yeah, I gotta raise them each to an exponent. This is why. Yep, so it's 81 to the 3rd, so it becomes 3 to the 12th plus 3 to the 12th. Similar idea with factor, yeah, yep. 3 to the 12th times 1 plus 1, 3 to the 12th times 2. So right off the bat, I know that's right. And I'm pretty sure the other ones with powers of 3 are not right. Right? Because if it's 3 to the 12 times 2, it can't be 3 to the 7 times 2, can't be 3 to the 24. Another way, another way to think about this, Brittany, that maybe you'll like better is if I had x plus x, it would be 2x. Same thing here. If my x is 3 to the 12th, then it just becomes 2 times 3 to the 12th. It's like the same logic we'd use with addition and algebra. We can use with exponents. All right. So I've gotten part way there. It wasn't super pretty, but we got there. I got there. You guys probably would have not been much better. I saw nice things from many of you. Which of these then? What do I need to do to think about the 9s? Yeah, 9 is 3 squared. So I could say, okay, 2 times 3 to the 12th, that's 3 squared to the 6th, because I multiply exponents. So I'm just changing the form. 2 times 3 squared to the 6th in place of 3 to the 12th. And that then becomes, free up a little space here. That then becomes 2 times 9 to the 6th. So this one is also right. This one is wrong. Problem solving is not always a smooth process. I think that's an important thing to keep in mind. To this day, when I see a new problem, I have to think a little bit about it. For if it's a particularly hard problem, I'm going to have to do some trial and error. So I think sometimes we expect like, oh, we see a problem, we immediately know what to do, A, B, C, we're done, very smooth. That isn't always the case. Can get tricky. And select all can sometimes be a little trickier. Not always, but sometimes. All right. Let's look at one that looks a bit different. Here you go. 20 seconds to think about it. All right. Let's start by talking about our goal. So this one here, we have a little bit more text. So what I often do is I read it all the way through to the end. I think about the goal, then I'll go back and process the information one piece at a time. But let's start with this. It wants cost in dollars per pound for the trail mix. So without getting into the actual numbers here, what's my goal? Like, what am I going to have on the numerator? What am I going to have on the denominator? Because I can see a lot of my answers look like fractions. So what's the kind of, what's the goal here? It's going to be, I'm going to need this, I'm going to need that. Just thinking about it in terms of actual things. We'll get into the numbers in a moment. Yay. Yep, nice. Cost in dollars per pound. When I see something like this with a per is basically saying division. So I'm going to need the total dollars over the total pounds. And I, again, often write things like this down, especially in some of the longer word problems or in the graph problems, because if I have it written down, I have this nice framework that I can then come back and plug things into. So I need the total money, total pounds. All right. So now I'm looking at my answer choices. So I see just variables. So all I have to do is write an expression with variables. Don't have to solve. Feel good about that. Looks like an kind of algebra, variables in the answer choice problem. Now I'm just going to go back to the beginning, one piece at a time. So trail mix is combining 3. So I have nuts with 3 pounds, and they are X dollars per pound. I have chocolate that is 1 pound, and I have Y dollars per pound. So I'm just organizing the information on my paper. And I have dried fruit. I have 2 pounds of that, and that costs Z dollars per pound. So right off the bat, I can say like, oh, I can find my total pounds. I can find my denominator. Just add these up. I always like to go with the easy thing first. You know, always what's the next easiest thing to do? Add these up. I get 6. And then, all right, so now I need the total dollars. So I have 3 pounds, X dollars per pound. Well, that would be, okay, 3 pounds times X dollars per pound. I like to write out the units sometimes, just if I want to make sure. Cancel out. So for nuts, it's 3X. Cool. So nuts is 3X. That means chocolate would be 1Y. That means dried fruit would be 2Z. Sorry, I made that really ugly and badly organized. But 3X plus Y plus 2Z over 6. Gotta be answer C. Now, sometimes I've seen these variables in the answer choices taught with plugging in numbers for the variables. Personally, I find most of the time that's slower. So I tend to always want to work with the numbers here. I have a question for you guys. Thinking about my process going through this, my approach, is there anything different from how you would approach a problem like this or a word problem? Is there anything you're like, oh, I don't usually do that, or it's a little different? Brittany, you said the process was easier. What made the process easier for you? Yep, yeah. Lots of info. Break it down. Organize it on your page. Make charts. I like to make a lot of charts, but take your time processing the info. It's gonna pay off in being more efficient and more accurate than like, I gotta go super fast and then it gets disorganized, it gets stressful. That's gonna make things worse. And as you study, a great thing to do a problem, then go back, redo the setup on your paper. I am not naturally an organized or methodical or particularly neat person, but I trained myself to be that way in order to take this test. I got hired, needed to get a higher score, worked a lot on my quant. And this is a big thing I do. I do a problem in my messy, chaotic way, and then I'd go back and I'd rewrite out a kind of better way to do it. And over time, my first solution became more effective. Yeah, yep. Felipe, I think that's a great point. Felipe chatted me that taking a step back and looking at what they were asking for first makes it easier to understand the question. And I think that's a great point. In today's class, we're going to do mostly moderate problems because I think, you know, people are coming from very different places and they're studying. But these techniques are also going to be very, very helpful for getting you to get up to speed with increasingly difficult problems faster. If you have a really good process, really methodical way of looking at things, you're going to find the really hard problems are not as scary because you're like, cool, I've got this process, I've got these tools to break things down. All right. Let's do another exponent one. All right. Here you go. 20 seconds. Don't start working. Just pay attention. All right. Here, I think what the question wants is pretty straightforward. What is 3 to the z to the z? What do our answer choices tell us about what we should do? Gotta simplify. And as I'm simplifying this, what are the answers suggest I should do or not do? Yep, I want to keep it an exponent. And what else do I want to keep? Looking at our answers. Yeah, yep, all base 3. So I definitely, when I'm setting this up, 3 to the z, I'm going to keep this 3 base here. And then I'll plug in z. Yes, I got a great question. Should we normally spend 20 seconds evaluating each question? I think it depends a bit on the complexity of the question. So I generally say somewhere between 10 and 30 seconds. 10 for a simpler problem, 30 for a longer problem. So especially also as you improve, you may be able to compress this or like kind of startup time, get it a little shorter. But if you find that you're tending to skip it and jump into calculating, just keep doing what we're doing today. Set a timer, whether it's for 10, 15, 20 seconds, and stick to it. So I can keep my base of 3, plug in. I know that 3 to the 4th equals 81 because it's actually kind of helpful to memorize these, like 3 to the 2nd to 3 to the 5th, 2 to the 2nd to maybe 2 to the 8th. Can be good to memorize all these powers. So I can rewrite this as 3 to the 81 times 81. And now I'm not going to do 81 times 81 in my head or on my paper. GRE has a calculator. I am going to pull up, normally I would pull up my desktop calculator, but I think it'll be faster for me to do it on my phone. But I'm going to use a calculator at this point to do 81 times 81. So you are allowed to sometimes use a calculator. And I get E. However, now that I have used my calculator, I don't think I really had to use the calculator. Why not? Yeah, yep, Tanya, Felipe, really, really nice point. 81 times 81. Always going to end in 1 because 1 times 1, I just multiplied the digits. So I could see either has to be B or E, and B is too small. I also think I could have just looked at 81 times 81, looked at my answers, and been like, 405 is way too small for 81 times 81. Yeah, Vivant, exactly. I did not need to do the calculator there. So I learned something. Look at the answers before you pull out your calculator. That's my takeaway for myself. Look at the answers before pulling out the calculator. This is also something I would really encourage all of you to do as you study. Did a problem? Go back and find ways to make it faster. Once you can do a problem, can you do it faster? Is there anything about your process that wasn't efficient? Because if you can make the things that you do well, that you understand as fast as possible, that's going to save you time for the things that are maybe a little more difficult, more of a struggle. Use your answer choices too. Let them help you. All right. Cool. Let's look at another one. Different topic. Same process. This process just gonna go over and over every problem. Here we go. All right. What topic is this problem about? What topic is this testing? Yeah. Decimals. Values of 10. I'll be honest with you. This is a problem that I would look at and I would maybe decide not to do personally. And it's not because I think this problem is objectively enormously hard. It's because for whatever reason, this is the topic that I cannot stand. Powers of 10. You know, converting billions to millions. We're dealing with like 0.03 instead of 0.003. I hate this. It's somehow really hard for me to think about this. Don't know why. So, you know, I would much rather do like the hardest combinatorics problem on the test than do a problem like this. So for me, and this is a reminder for all of you, you are allowed to have a topic that is like a certain skip for you. Like I don't do probability. I don't do cylinders. I don't do powers of 10. So I'm going to lean on you guys to help out with this one. I'm going to start, I'm going to process the information. So he divided the number by 0.03, should have divided the number by 0.0003. Kind of got it organized. I need to correct the mistake. What would you guys do? What technique or approach? Oh, great question, Julia. I would guess, always fill in a guess. I would guess, I would mark it. And then if I had time at the end, I would come back for it. But it's the kind of thing where I'm like, this is gonna just stress me out if I do it right now. Oh yeah, so folks are saying work through the answers. Definitely gonna be, that makes sense to me. What else might I do to kind of set myself up to work through the answers? Ooh, cool point, Charlotte. Yeah, think about what you know about the topic. Okay, when I divide by a decimal, when I divide x by 0.03, it's going to get bigger. So this is going to be greater than this. The wrong is going to be too small. So we need to make it, we need to take this and we need to make it bigger. Yeah. Yep. Nice. We're on the same page. So let's think about that with our answers. If we multiply it by 100, will we make it bigger? Yeah, that makes sense. We divide by 100, not going to make it bigger. We multiply it by a decimal, that's going to make it smaller. We divide by a decimal, that's going to make it bigger. You guys made that so easy. I feel great about this now. Thank you. Just by remembering a simple pattern in decimals. Divide by a decimal, divide by a fraction, it gets bigger. So if I divide by a smaller decimal, it gets even bigger. And then since 100 and 0.01 are kind of the same, I mean, since I have both hundreds here and both 0.01s here, I don't need to worry too much about the like actual number of zeros, number of terms. I just have to think about what makes it bigger, what makes it smaller. Really nice, guys. Nice suggestion for a super efficient way to do this. I like it. All right. Let's move on to a different topic that I almost didn't bring that problem because I was like, I hate this topic, but then I was like, no, this is going to be good to do. And now I'm really glad we did it. Here's our next one. All right. What is our goal? What are we looking for? Yep. Ooh, yeah, yep. So we need to find the fixed annual expense. Nice. And I saw a couple of people saying that's going to be a variable. This is an unknown. So I might right off the bat say, okay, I'm going to call this F. A fixed amount, and I'll just put a box around it to remind me. So got my fixed annual expense, got my goal. Looks like maybe kind of an algebra equation translation problem. I've got numbers in my answers, so I'm going to be able to calculate an exact number. Where should I start? I'll let you guys decide. What should we do first here? Yeah, Tanya said create two expressions. I like that. Yep. So I'm gonna start, same thing as always. I've read all the way through. I'm gonna go back and I'm gonna take just maybe a moment to process this. I'm gonna say, okay, annual expenses. So the total expense equals a fixed amount. So that's my F plus some kind of variable that's related to the number of clients. So like, you know, maybe they earn, if I'm not clear about what this means, like I try to imagine it, I make it concrete. So like, all right, maybe they, you know, pay $100 in rent over the whole year. This problem is set in 1901. They pay $100 in rent over the whole year. And then they also have to pay like another $1 for each client they work with. So there's something that's always the same, something that's dependent on clients. And I just take some time to understand that pattern to really make it concrete and like get confident about it. And now I see that I have two unknowns. I have F and V. I have a fixed cost and the variable cost. So Tanya made a great point. If I have two variables, I'm going to need two equations. And I also have two sentences that give me information. So that's going to be good. So I'm going to start here. All right, so 2009, what happens? Total expense, 830,000. And that's going to equal my fixed cost plus whatever that variable cost is times 450 clients. And then I do the same thing for 2010. I have 896 fixed cost plus variable times 510. Now I have my system of equations. We saw this earlier. Two variables, two equations. What do you guys think? Should I substitute or should I stack and add, stack and subtract here? Alina, I am on board with stacking. Yeah. Yep. Why is that a good idea here? Like, how did you guys make this decision? All right, we're going to stack and subtract. Yeah. Like when I have these variables kind of lined up, it's going to be hard to isolate, but it's not going to be so bad to subtract. So this comes out to 66,000 equals F plus 60 V. Sorry, F goes away. 66,000 equals 60 V. I'm going to use my calculator. I probably shouldn't. I feel a little shy about using my calculator after I called on it so unnecessarily, but I'm going to do it just because, I don't know, it's kind of late at night. I don't want to make too many more mistakes. So I get V equals 1100, but I'm looking for F. So now I need to plug that back in to one of these equations. So I'll maybe do this equation. 830 equals Yep, I divided both sides by 60. Yeah. Equals F plus 450. And again, I'm going to bring out my calculator. Probably should be not using my calculator so much, but like I said, I am quite tired. So I'm going to do it. And now I can just solve for F. Get 335. And that's our answer. Anyone have any ideas? You know, there's a fair number of steps here. Is there anything I could have done to make my life easier? I subtracted. So I did 830,000 minus 495,000 to isolate F. Minus. Like that. Yes, take away the zeros. That's what I should have done. Just take away zeros. I'll add them back in at the end. Then I would have gotten 335 and I would have just added the zeros back in. So when you have a lot of zeros, take them out, work with it without the zeros. That's going to be a lot easier. Emily Lynn, I have two Emilys. Emily Lynn, I am not convinced that plugging in answers is going to save me time. Generally, I plug in answers, I back solve if the answers are small integers. That's definitely when I'm like, okay, maybe I'll back solve. But when the answers are pretty big like this, there's so much calculation, it's probably going to be faster to do the algebra. So yes, sometimes I think back solving from the answers can save us time. This is a case where I think that most likely for most people isn't going to be faster. Might be if you're like very fast with arithmetic and hate algebra, so I won't tell you don't do it. But I think just, yeah, be wary. This is a good general point actually about sort of algebra solutions versus back solving picking numbers solutions. If you always want to do one or the other, like you're an always algebra person or an always pick numbers person, push yourself to get more comfortable with the other method, because there are going to be places where using the other method is going to save you some time. All right. Here we go. I'm going to set a timer. Okay. What topic is being tested here? Yep, slope, so it's part of coordinate plane. Nice. And what do the answer choices tell me about what I should do to start? Yeah, yep. I think, yeah, I want to get it nice, Garrett, Alina. I see all of the answers are y equals something x plus something else, our classic slope intercept form. So m represents the slope. So I want to get it into that form. So I have 4x plus 5y equals 9. Subtract 4x from both sides. I get 5y equals negative 4x plus 9. Divide both sides by 5. And I'm good. I now know the slope of this line is negative 4. That's the whole point of slope intercept form. Makes it super easy to know the slope. What makes a line perpendicular? So if I think about, I'll draw a perpendicular line, but how do perpendicular? Yeah, nice. So my line, if this line is kind of going like this, perpendicular line is going to intersect it at a 90-degree angle. So here, this is -4/5. That means my perpendicular line has to be positive, and I flip it around. I take the inverse. So I change the sign, and then I flip numerator and denominator. It's going to have a slope of 5/4. There's only one answer that has that. Use the answers. You're so helpful. They tell you so much about what you can do, about what you should do. Something I'm noticing as we go through these problems is that I don't always answer all 4 of these questions. I usually answer a couple of them, depending on what's happening in the problem. So I have this mental checklist in my head, but I'm kind of seeing, okay, which of these 4 do I want to answer? Is it all 4? Do I need to just answer a couple and then I know what to do? So I have options for what to ask myself as I start. May or may not ask all of those things. All right. Let's take a look at this one. Felipe asked a great question. What if multiple answer choices had 5/4x as the slope? It would not be a fair question. If they're asking you to pick one, there can only be one that's possible. And any line with that slope is perpendicular. So there could only ever be one answer. Or if it was select more than one, then you could have multiple lines. Then you'd pick all of them. Great question. All right, last one. All right, this one's a bit trickier. So here, I see its probability. I see it's kind of complicated. So I might just pick out one thing. Okay, multiples of 9. How do I know a number is or is not a multiple of 9? Ooh, yeah, I got it in the chat. Digits add up to 9. So maybe I'm just going to start thinking about that. Digits sum to 9. So I could start thinking about that. I also know its probability. What's my core kind of formula for probability? If I'm just making one choice, how do I calculate a probability? What's our core, the kind of base core fundamental? Yeah. Yep. So it's like the outcomes that I want, the sort of like selected outcomes over the total options. And here I'm saying, okay, I'm picking the tens digit randomly from 10 different digits. So I know right off the bat, I can fill in this. So all I have to do now is figure out what's this number that I want. And I know for the number that I want, it's gonna sum to 9 or to a multiple of 9. That's my rule. So 8 plus 9 is 17. 17 plus 0 is 17. That doesn't work. 17 plus 1 is 18. That does work. 17 plus 2 is 19, 20, 21. You know, I'm starting to get the feeling, all right, these are not gonna, 23 is not gonna work, 24, 25, 26. None of the others are gonna work. There's some ways I could have figured that out sooner, but sometimes in the moment, I decide like I could reason this out and think about it, or I could just mechanically write out all the options and do it that way. And if I'm tired like I am right now, I'm going to just go for routine mechanical thing I know will work rather than having to get super fancy. So there's only one that works. 1 divided by 10, that's 1/10, same as 0.1. So this is a problem that I think looked, when I first looked at it, I was like, ooh, I did this to us tonight. But then once we kind of pull it apart, you know, take apart the different pieces, it's not so bad to put them back together. Cool. All right. I want to pause there with problems, but I have one more thing for all of you to do. One thing is for folks who are newer, I hope seeing a lot of different math wasn't stressful. Yes, any multiple of 9, the digits will all add up to 9 or a multiple of 9. So like 18, 27, but they'll add up to a number that's divisible by 9. But maybe if you're starting out, this will help you figure out kind of what are some of the topics you might want to dig into more. Other thing that is super, nope, that rule is just for 3 and 9. There's other rules for some of the other numbers, but that one's just for 3 and 9. Yeah, good question. Other thing that you should do at the end of every study session is just recap for yourself. What do you want to remember? So before we go, everyone in the chat, what is one thing that came up today that you think might be useful for you to remember? Can be something about process, can be a fact, can be big or small, anything that comes up. Time to read, process the problem. That's a great one. Answered. Drill rules. ID what question is asking. Select, skip, and revisit topic. Simplify. Cool. Yeah, yep. Yeah, don't freak out. Break it down. Nice. Yep. Yeah, try new methods to find more efficient approaches. Yeah, multiples of 3 and 9. Digits add up. Nice. These are great. Yeah. This process stuff, you know, the content stuff is good. You'll get the math content back. Process stuff, super, super, super key. I think super important to remember in both quant and verbal, but maybe especially in quant. The last thing I will leave you with, this is not really a math test. It's a test that's using some math concepts to test other types of skills, our time management skills, our problem solving skills, our decision-making skills, how we perform under pressure. So just keep in mind your process, your approach, these problem solving tools that you're building for yourselves. These are going to be just as important as learning the math content. And if you are someone who has had a bad relationship to math in the past, that is me, you can definitely get to a place where you do well with GRE math because it's a bit different from what you will have done elsewhere. So that's my pep talk for the end. I got a great question. How reflective are the Manhattan Prep practice tests of the difficulty of the actual test? I think difficulty-wise, our quant is pretty aligned. I think our verbal skews a little on the hard side. Like I see a lot of my students scoring a little bit higher on the official test verbal than on our practice tests. I think in particular, the vocabulary on our tests is a little scary. So if you took it and you were really scared with the vocab in particular, it's not going to be as bad, I think, for most on the official test. Yes, we should do a data interpretation video. It has been a while, Shristi. So I think that's a great idea. And I will, I'll figure out who's teaching the next free prep hour. I think it's maybe Wit. I'll see if she wants to do one. That would be great. All right, guys, that is our time for tonight. Thank you so much for being here. It was nice to have a big group. I hope you got something helpful wherever you are in your studies. And if you're just starting out, come to more of these. They happen twice a month. Look up the recorded ones on YouTube. Lots of great stuff there to help you out in your study. Have a lovely night.